Hi everyone, Mr. C again with another video just going over again some of the basics that we looked in class on Thursday. I'm just going to pick up where we left off in the last video. I've got stellarium running and we're looking south again as we usually do. Well, right now I've got it set to the current time, which is a little bit before 6 in the evening, as we can see down here. We're on January 11th. And like we saw in the last video, twilight is passing, stars are coming out, we've got Jupiter visible here. We can see some of the same bright stars that we were looking at before. Okay, so we've seen some of the basic things in the sky. Let's just hit a couple of other concepts and review these. Now, by the way, although I get a big kick out of making these videos and shooting these things and uploading them, the really important thing for you to be doing is to be playing along with Stellarium. Sure, it's easy to watch me illustrate the concepts, but one of the things that education research has shown is that when you take some tool like, say, a planetarium program, and you play with that tool and you fiddle around with it yourself, you'll learn a great deal more than you would otherwise learn if you just watch something or read something. So it's a really good idea for everybody to actually download the software and just play around like I'm doing right now. I'm just doing that left mouse button click and drag in order to look around the sky. Just panning around the sky and playing around with time controls like L and K is really good for starting to learn your way around the celestial sphere. So that's what we want to hit in this video, some of those concepts about the celestial sphere. Now, in the planetarium dome, it looks like the inside of a sphere, or at least half of the inside of a sphere. So the idea of the so-called sphere of the sky kind of makes more sense there. In many different cultures for a long time, maybe since antiquity, a lot of people thought of the sky as literally a domed roof, like the one in the planetarium. There were some ancient philosophers and thinkers who thought that it was close enough that a really loud war cry might get an echo from it. Nowadays, we know that the sky is not simply a domed roof over us. It's empty space stretching out, maybe not infinitely, but incredibly far into the distance, and the stars and planets are scattered throughout this space. But the illusion that we are at the center of a large sphere is extremely powerful. So you want to make sure to look at the pages in the textbook that talk about the sky around us, because that illusion is very powerful. And if we understand how things move in terms of this imaginary sphere, then we can start to think about the real three-dimensional space beyond us. Okay, so let's think again about these compass points on the horizon. There was our south point, as we've seen before. Notice that if I turn to the right, that's in that direction, we would get around to west. I continue turning my field of view rightward along the horizon, and I would get to the north point on the horizon. And I could keep on going, and I could get to east. Let's review what happens in east and west. As we saw in class the other day, and as I think most people know from everyday experience, the sun and moon and stars all appear to rise in the east. So we can make time go forward and see things rising in the east. Now, here's a question to ask yourself. Do things rise directly straight up into the sky in the east? Well, here in California, around San Jose, it turns out that they don't. As we go forward in time, you can see that these objects are rising diagonally upward from the horizon. That's an important point that we'll hopefully have time to get to in the planetarium, and this has to do with where you are on the Earth. If we swing around to the western part of the sky, we can see things setting over there. We can move time forward and see objects setting. Again, notice that they're coming down diagonally toward the horizon. There are other places in the world we could go where that might not be true, but at most locations on Earth, stuff is either going to rise or set diagonally toward or away from the horizon. Remember in class when we were in the planetarium, we compared the south sky with the north sky. Let's run time forward in the south sky, and notice what's happening here. The stars seem to move roughly from left to right. They kind of rise over here in the east, they move upward along an arc, and then down toward the west. Right near the southern part of the horizon, they're moving almost horizontally. You can see these things just trucking along from left to right. And then remember, we compared that with the northern horizon. Remember how I turned one of the controls on the planetarium and I made the sky turn like this. That's so that you didn't all have to get up and basically look in the opposite direction. I just brought the sky around to you, like we're doing now. And remember, you always want to take the stellarium and do this for yourself. The more you get accustomed to playing with this yourself, the more you'll understand the concepts and probably the better grade you'll get on the test. Okay, so here was north sky. Now what we want to do is we want to make this move forward in time. And here you can see that the sky seems to be rotating around roughly this star here. This point is called the North Celestial Pole. Now here's a really slick way to illustrate that in stellarium. Down here, as I mentioned in one of the other videos, you have a couple of grids. This one here is really useful for understanding celestial pole. It says equatorial grid. This is how astronomers map the sky. You might be familiar with concepts like latitude and longitude on the Earth, where we can measure how far north or south we are and how far east or west we are. Well, we do the exact same thing in the sky. Even though the sky is not really a big sphere, for the purpose of mapping it, we can pretend that it's a big sphere, and we can put this grid on it. Well, from our latitude here in Central California, this is how the sky's system of coordinates looks. We don't call them latitude and longitude. We have other terms that we use for them. The ones with the degrees are called declination, and the ones with the H's for hours are called right ascension. Those terms aren't critical to us right here. That's not what's so terribly important. The main thing is these form a map grid where we can give positions of stars. If we run time forward, you can see that as things move across the sky, the position of a star, like Procyon here, doesn't change relative to this map grid. We call this one the equatorial grid, so we use it for mapping the sky. If we turn around and look at the north sky, you can see that some of the lines all meet at one point. That's the North Celestial Pole. And you can see that this star, Polaris, is almost exactly at the North Celestial Pole. Not perfectly, but almost. And so there goes the sky appearing to rotate around the celestial pole. So that's another of our vocabulary terms and another of our important concepts, celestial pole. That's simply the direction toward which the Earth's rotational axis points. So as the Earth turns on its axis, it gives us the illusion that the sky is turning around that point. There's another term that's worth knowing, and I think I've got this on the vocabulary list, and that term is zenith. That's the point directly overhead. Now here's a good way to see that. Come down to this toolbar, turn off equatorial grid. We just get back to the regular old sky. I'm going to right-click to turn off my Polaris information. And then I'm going to go down here to azimuthal grid. We don't have to worry about that term azimuthal, but this grid is not attached to the sky. This grid is attached to the Earth, or at least to our illusion of the Earth being a flat disk. The Earth is not. It's a sphere, or at least close to it. But in the powerful illusion that we have here on the Earth's surface, it seems like the Earth is a flat disk inside the sphere of the sky. And so we attach an imaginary grid to that imaginary flat disk of the horizon. And the point directly overhead right there is called the zenith. You can see that right now at about 6:38 in the morning, this bright star Arcturus is pretty close to the zenith. And if we continue to run time forward a bit, you can see the stars don't stay attached to this grid. They move relative to the grid. And the stars are fading out because sunrise is coming in. We can always turn off our atmosphere and eliminate that problem. So you can see stars moving relative to this grid that's attached to the horizon. And that point directly overhead is the zenith. If you lay out on a blanket on some clear night and you're looking straight up into the sky, the stars that are passing directly overhead, as seen from your location, they're going through the zenith. So here comes the star Vega. It's going to go almost, oh man, that's close. That goes really close to passing right through the zenith as seen from the latitude of San Jose. So those are some more of our basic concepts. We had celestial pole, we had zenith, we had the different motions in the sky. Again, if you play along with stellarium, it can be really helpful for helping to understand these concepts.